Well, good afternoon, everyone. Oh, can I hear myself now? Okay. And welcome to this session on how we can leverage OpenAPI for something you might not be used to, which is the security. I've seen a lot of talks until far about a lot of things that can be done with OpenAPI. Not that many people talk about security, which is what I'm going to talk about now. So I'm the field CTO and one of the co-founders of 42Crunch. As you can imagine, we're related to API security. That's what we do. I have an API security platform. This is not a product talk. It's really about more the principles that we have adopted, but which have also been adopted by other companies and other open source projects that you can leverage to actually do security and enhance the security of your APIs, leveraging specifications, okay? So what I'm going to talk to you about today is really about a subset of what probably is the overall API security problem, right? This is a very hot market right now. A lot of people are talking about API security across the board. And there's different aspects to it. There's a lot of things that have to be done in order to achieve overall API security. And it could be looking at your libraries and see if there are not, an old version that contains tons of problems, or it's a container image which have been poisoned and has some Trojan horse in it, or looking at your code. Right? What I'm going to talk about here is really about app layer, right? About this layer of responsibilities which are now landing mainly on the developer's lap in terms of their responsibility when they create a new application. More and more is actually landing on the responsibility of the development teams, right? So we're going to focus on that, right, on the app code part. So if you look at what OpenAPI allows you to describe, what do we have? Well, we have obviously the security schemes, like how are you going to consume my API? What I'm going to ask you to provide me some tokens, some authorization, something in terms of the security to get access to my API. Then everything related to how do I call this? What are the different methods? What are the verbs which are allowed? What are the parameters, the formats, the constraints? What is the data, which is something very critical and important in APIs, right? And we're also working on a number of things. You may have heard this morning talking about the SIGs, the special interest groups around OpenAPI, and there's a bunch of them to provide some extensions on top of OpenAPI core that would be very probably interesting from a security also standpoint. For example, SLAs, like we all have in our products and everything we use, we have rate limiting. For example, how do we express those? We can't really express any service level agreement within an OpenAPI file as a group working on that. I'm involved more in a specific security one, like how do we do JWTs? What is a JWT? What can I describe that? How do we do signatures, encryption? And the last one is also workflows, which is very interesting in terms of describing this is the expected behavior of my API. When somebody uses my API or a set of APIs, first they have to call operation A from API 1, and then operation B from API 2, and then operation C from operation 2 maybe as well, from API 2 as well, in that specific order. And if somebody starts coming in and calling things in whichever order, that doesn't really make sense from an application point of view, probably something is wrong and you want to stop that, right? That's probably from a security standpoint, somebody's doing some maybe discovery on your API, trying to find out it works, and it doesn't really follows the pattern that is supposed to be followed if this was the real application leveraging the API. So there's a lot of information we can capture that can help us from a security standpoint, right? Now, how do we leverage this? As you know, obviously, OpenAPI, at the beginning, it was all about documenting and being able to, we go way back on when API management was born and governance was born. All of this was born from the need of expressing internally or externally, hey, this is my API, that's what it does. If you want to consume it, you don't have to come and talk to a human, right, basically. You can go and look at that portal and it will tell you how to consume this thing, right? That's kind of the origins of all of this. But since then, it has evolved in, as we know, API first, being able to generate even our implementation from an OpenAPI definition, mockups, SDKs, testing from a functional testing point of view, right? And for me, it enables something I talked about yesterday when we talked about DevSecOps, which is security as code, right? It allows us to describe what is, from a security standpoint, the expected behavior of our API, so we can then test that behavior first, and then enforce that behavior. And this is much of what we're going to talk about today, okay? So this is a nice picture. This is something we just came up. If you want to go have a look at it, we created this like maturity model for API security, because this is one of the main things we see people is they say, we don't know where we are. We look at API security as a whole. Where are we from a governance point of view? Where are we from an inventory point of view? Do we know what we have? Do we know how to automatically test our APIs? How do we do protection of our APIs? So how good are you across those 6 different axes, I would say. And what I'm going to tell you now is just take this design, inventory, testing, protection, and see how we can leverage OpenAPI in each of those axes, if you want, to do better in terms of design. So we'll start with design, okay? So first thing, this is what I see in many, right, many APIs. There's a lot of decisions that you have to take when you design your APIs that can potentially become extremely complicated as time goes, and the later you discover those problems in the API lifecycle, the more complicated it's going to be to actually address that problem, whatever it was, right? Maybe you're leaking some sensitive data, maybe your authentication is not at all adapted to what the API actually does and the data it transports. So you have to, as I say, stop and think, right? Because if you have this in your house, you're in trouble, right? You're gonna break your leg like my poor friend there in the back, right? That's gonna be really hard to fix. And we have plenty of customers that tell us, we are gonna put this thing in production and we're just gonna cross fingers that nobody is gonna find all the problems we have until we actually fix them. And why is that? It's because those design problems that have been found very, very late in the API lifecycle, to the point that they cannot just say, stop everything, don't deploy this, because, well, we have the business that wants this to be deployed, and we have to, right? So they just let it go, and then they just take some emergency measures to correct whatever is wrong, to create a new version that fixes all the issues, right? So how is OpenAPI and maybe specifications in general, if we talk about async API for anything which is asynchronous, right? WebSocket based, etc. How is that helping us, from a design perspective? Well, because it's going to force us to kind of lay down the foundation of, okay, this is what my API does, and we can just all look at this and agree on this is the data. We can look at, is that indeed sensitive data, non-sensitive data, analyze what is the data in, what is the data out, what are the different operations. Erez this morning in his talk on API security top 10 was talking about access control being the #1 problem. We see this every time. And why is that? Because we have not designed properly, again, what are the implications of opening, search and trust operation to certain people, like admin people. Like I see a lot of people mixing data, mixing operations which are like standard user operations with admin style operation into the same API, right? Why is that a problem? That's a problem because maybe what you do is you say, well, that's okay. The admin endpoints, they're here, but I'm going to create something that hides them. So from an external point of view, nobody should know that they actually exist because I'm not going to advertise them. But they're here, right? And it's really easy to discover them. Like, data dictionary attacks that hackers are doing. We're usually not very inventive as humans when it comes to naming endpoints, right? It's going to be called /admin/ whatever, users, right? Everybody's going to call it the same. So it's very easy to do like a dictionary attack for a hacker, go and find straight into the API, even if it's not supposed to be there. They will go and make those calls until something hits and say, ah, okay, so there is an admin endpoint. It's even called admin, fantastic. So I know it's an admin thing, right? And that becomes my entry point into the system. So you have to design for that. It's not because you're not advertising something that it's not there. Wouldn't we be better if we were separating those two, for example, and make sure that this admin thing is only accessible from a very specific, whatever, network, maybe it's in mutual TLS, whatever it is, but we need to design that so we're sure that only the people who are supposed to access that actually have access to it. So you need to design that, again. If you don't do this from the beginning, you're gonna have problems, right? So every piece of data, we need to know about this, what are the paths, what are the verbs, all this information. And all of that we can capture in that contract, right? The other thing is data constraints, right? So everything is a string, which it is. Well, but not every string is equal. So give me more information. If I stand saying that a lot of the problems we have on API security today could be avoided if people just did standard input validation on all the data. If they knew, hey, we're expecting a credit card number. That's the format of a credit card number. Anything that is not a credit card number should never be accepted because that's not what we want. Okay, but we need to know that, right? We need to describe that. And there's enough now richness in frameworks. So should you start from the code and annotate your code like what you see here on the right, which basically will generate an OpenAPI file that has those limitations, so it cannot be null, and it has a size of between 0 and 20, etc., right? So we have that information. There could be a pattern in there, whatever you want it to be. You generate the OpenAPI file and you have this. Many frameworks will actually, if you have those annotations, like in the Spring Boot, for example, or in Flask, they will at runtime make sure this is right. You know? So when the data comes in, they will validate that it's actually between whatever, 0 and 20 in that example. So if something comes in and it's a size 400, right, it's going to be rejected automatically by your framework. But the framework cannot do that if they don't know what it is that we're manipulating, right? So that will give you automatic input-output validation as well. And why does that matter? So again, I'm going back to you guys all familiar with the OWASP top 10 for APIs? You've seen that, most of you, I guess, yeah? Okay, if you haven't, check for that, OWASP API security, right? And here, this is really critical to basically three things. Actually I'm missing, to injections, right? Well-known injections. So if we do validation of the data, we wouldn't have so much injections, right? Mass assignment, which is another story around making sure we cannot trigger, I would say, the update of data in the backend from input information that is not supposed to be there. The typical problem there that we've seen multiple times is people just saying, well, I want to update my user profile, and usually to update my user profile, the only thing I can do is to change maybe my email and my address, right? But if put another property that says role equals or is admin equals true or role equals admin, I'm not supposed to put that in there, right? I'm not even supposed to know I could put that in there. But because behind the scenes, what the framework is doing just says, okay, I have this nice JSON object. I'm just going to take it as it is and put it into the database, right? And right away, boom, that's it. I'm an admin, right? That's mass assignment. So I'm taking data in that I'm not supposed to take in, right? So that's another piece of control that you have to put to avoid that. The other thing you're going to avoid with this kind of constraints is anything linked to overflows, right? So what happens if I'm sending you a title here with 1 million characters? Have you tried that? Right? So how do we enforce that? So again, so constraints are a bit painful to put in place, but they're very important because also you have a database and something in the back that has some constraints. So you want to make sure there's no data that reaches all the way to the back that actually is not even compliant with what your database is saying. My database has a user ID, which is 256 characters. Why would I accept in the entrance of the system something that is more than that? It's not going to work. It's going to fail when I'm getting at a database level, right? So if you capture those, then we'll be able to take advantage of this, as you will see, okay? So you know the data. I see this all the time from customers that in the description, they say, this is a UID. Fine, then if you know, or you know, description, this can be checking or savings. That's it, you cannot put anything else. So what you have to do is really put this as a constraint, right? If you put this as a constraint like this, okay, it's a UID. Well, it's a UID. It has a max length of 36. It has a well-known format, right? Same thing here, checking can be checking or savings. So what will happen if you do this is when you do a control and validation against that information, it will be rejected if it doesn't match this information, right? So those constraints are really, really important, okay? Other things that we see all the time, a lot of the APIs that we see and we analyze in 42Crunch just say, I have a 200 and it works. That's it, right? Okay, so first of all, sorry, no, your API will fail from time to time. It will send maybe just a 4 or 3 to say somebody is not authorized, if that. Or I'm going to send you some bad data, and you send back a 400 to say this is a bad request. And when you do, you will have to send me back some data. This here says 200. That's it. Well, no. There will be a response coming. There will be some information coming in that 200. Tell me about it, right? So all of this you need to design and specify. And one thing which is really, really critical about APIs is in security, traditionally, we've been focusing on requests, at looking at traffic coming into our data centers, then comparing that traffic against a set of known signatures and patterns that we know are significant from a potential attack, like the injections and the cross-site scriptings and all this cool stuff we can recognize, right? But none of the traditional security tools today are looking at the responses, right? And this is really critical. You have to design responses and you have to look at responses. Why? Because you're returning a lot of information that potentially will become visible as soon as somebody talks to your API directly. So you need to control how much data is being returned. I've had multiple calls, discussions with people here that all say this is a big problem. How do they control that a developer doesn't put in a response some specific information from their customers that that's not supposed to be there, for example, right? So you need to control this data. And there's a, you know, again, in the OWASP top 10, there's a specific entry for this, which is, as you can see, in the top 3, which is data leakage, right? And so I don't know if you know how the OWASP is actually working, how this top 10 is actually being created, but the order obviously matters, right? The order in which these are made is by how frequently is it occurring, of course, but also how risky and critical it is, right? So as you can see here, and there's been numerous examples of this. So as 42Crunch, when we started the company, we also started this site on this, that's called APIsecurity.io. You guys know APIsecurity.io? You get the newsletter, maybe? Some of you? 2 good people, very good. Well done, Lorinda. So if you don't have a look, this is nothing to do with the product, right? It's not a marketing thing. It's really about education, right? It's about reporting the breaches, the tools, anything that can help you learn more about API security. And if you look at the breaches, you know, we've been doing this for 4 years now. We come into the 4th year of APIsecurity.io. And you'll see a lot of this data leakage and exception leakage problems, right? So controlling the data that comes out is really critical. I guess what we're talking about here. So we want to know about that data and describe it. Okay. So how is my, complete as secure is my contract? This is like where we have the, plug into a plugin that we do that you can download and try. You can plug into this into your existing IDE, and it will tell you about all this, right? It will tell you, hey, you're missing information. Hey, you're not strict enough here. hey, you don't have all the responses. So it's made for the developers, so as they go and they develop their OpenAPI files, they can get all this, ready information within their IDEs on making them better from a security standpoint. So this is all free. Plenty of people. It's kind of usage limited, but that's all. Full functionality if you want to play with that. Okay, so that's design. Okay, now the next thing is really inventory. Right, we cannot secure what we don't know. So that's one of usually the main problems that the customers that we work with bring to us, especially if you talk to the security side of the house, right? Which is, we don't know what we have, right? We know we have hundreds of APIs. Some of them are in this system in API management 1, others on API management 2, others are in no API management at all, probably. So we need to know what we have. So as Jean was saying this morning, it's all about the thing of like plugging ourselves into the production traffic, because as she was saying, the testing traffic is pretty low. And anyway, if you want to see those bots and those things which are getting your way, you have to plug yourself into the traffic, right? But what you want to do, the end game cannot be just to listen to the traffic for the sake of listening to the traffic, because otherwise you're not going to fix anything, right? You need to take this traffic, you need to generate the definitions out of this traffic, and you need to keep those definitions and enhance them, so you keep them under control. If you just listen for the sake of popping some alerts, you're not fixing anything, right? So the idea really that we're pushing is, okay, you listen to the traffic, you generate those specifications, and you put them back into the flow of the design, of validating them, testing them, as we will see in a minute, and enforce the traffic based on that. Right? So that now, you want to reduce that divergent, that drift, I would say, between what you think the theory is and what the reality is. At the end, we need to govern all those APIs, otherwise we're not fixing the problem, right? But the great advantage that OpenAPIs and our specs have is they allow us to have a single way of, describing what it is that we're dealing with. When we're talking with security people, they always tell us the same thing, which is, okay, so I have all those teams I have to work with. Some people gave me OpenAPI files, others give me curl commands, others give me postman collections, others give me an Excel and say, go have fun. It makes the life of the security guys really, really complicated, right? So if we can all talk the same language and talk a language which helps everyone, it helps the security people and it helps the development people. That is really our goal. That's what we're pursuing in our company, right? Have a common language so we all agree on what it is that we're deploying and exposing here to the world, okay? All right, now testing. And this is like, I've heard a lot of things about testing from OpenAPI now. It looks like this is a big trend. Why? Because it allows you to do testing at scale. The big problem people have today is they don't have 3 or 4 or 5 APIs, they have hundreds of APIs, right? And to do testing at scale, then you need to have something that the developers are creating that you can use to drive tests automatically. That's what our friend here has been presenting this morning, this REST test or Microsoft Wrestler, this kind of environments. We're doing that as well, right? So there's multiple type of testing, but you can really leverage all the information within an OpenAPI file to do automated testing. Like when we do testing in our environment, we probably do 50 to 70 tests automatically from every single operation in an API. There's no way anyone is going to write this manually. It will never happen, right? And more importantly, every time your API evolves, which it does all the time, or every new APIs are actually popping up, that's it. They pop up, you have a description of them, you run testing automatically. Functional testing, security testing, load testing, any kind of testing. As I always say, you probably want to have 10 times more negative testing, like hacking stuff, right? Than you want to have functional testing. We all test the 200 OK, that's all cool, right? But we have to test for those things we have specified, which are the constraints, which are, is my API respecting its contract? Is it, if I'm hammering it with bad data, what happens? Does it react properly? Does it fail with the 500, as we were saying this morning in the presentation? What is it going to do? What if I don't send any authentication? What if I'm sending wrong authorization? All of this, there's no way you're going to scale that across hundreds of APIs if you don't have an automated way of generating all those basic tests, really. That's what we want. So what do we have available? Well, plenty of stuff, right? I'll have to extend that list with your tool now. In the traditional security world, there are some tools like ZAP, which is also something from OWASP, right? A lot of those are adding OpenAPI support simply because traditionally what those tools have been doing is they first have to do what they call a scan to discover what is available, right? When you're giving those tools an OpenAPI file, it's like you avoid that step if you want, because you already tell them, no need to discover, this is what we have. Now go and send, fuzzing information to all this. So ZAP is really like the open source fuzzer from the OWASP Foundation that does some of that. It's going to do some testing more around SQL injections and cross-app scripting, the kind of traditional AppSec type testing, right? Burp is more something that's usually used by hackers. It's a professional tool used by hackers, but also have an OpenAPI module in there. And Portswigger, where the guys are actually doing this, have a great, again, from a learning experience, they have a great set of blogs on attacks and what they're doing, how their tool is actually working. There's a lot to learn from that. Microsoft Wrestler, so that's another thing. That's a fuzzer from Microsoft. It is quite advanced in what it does automatically from OpenAPI, also a lot of fuzzing. There's this thing from Yelp, which is called Fuzz Lightyear. This is very specifically looking at something which is IDOR or BOLA. So this is the API 1 in OWASP top 10, which is really about making sure that you have a proper authorization framework in place, so that if I'm connecting to an API and accessing a specific resource, like I'm getting to my bank account number 123, right? I cannot go and change the requests in the API to say I want to go to API to resource 456 because it's not mine, right? So I'm a valid user, I have access to the API, I have a valid token, but I don't have access to the data. So you really, really, really need to test for this, right? And so those guys, they've created this tool which allows you to create some scenarios, if you want, that allows you to do that. And this is something that we're doing as well. So here we are. We have a tool we call the conformance scan, which does exactly that as well. And we're enhancing that now to test scenario, where it will feed itself from the OpenAPI file and start hammering it with all kind of bad data as well. I think the main difference between the others and what we do is we're thoroughly looking at the responses to make sure they're actually compliant with the schemas as well. So it's not only about looking at the response and say, hey, you're answering to me a 400 or a 500 when I expect this to fail nicely, is we will look at that 500, so okay, do you have a 500 declared in your contract or not? And if you do, is that response in line with what the contract says? So it should be a JSON with a certain format. So we go a bit beyond just to make sure that the actual contract that you have defined is respected also from a response point of view by your API, right? So we're sure we don't let, this is very important to get from that data leakage that I was talking about. So we want to make sure that the data that's being returned is actually the one we want to return. So we don't have somebody that has added some extra information. So I give you an example from a POC that we did about 1.5 years ago or something. And we basically deployed our tooling in front of let's say a banking API, right? And about 2 hours after putting the protection in place, so we have a runtime piece that enforces the contract, some people come into the management and say, our application doesn't work anymore. It's like, what do you mean? Well, we don't know. We have this thing in the middle, this 42Crunch thing, it broke our application. And we were just looking at the logs, and we saw that what they had done is they had circumvented the API management within the company, went with their app straight into the API. They had implemented admin things at the API level that were not supposed to be there, right? And that's what we were blocking, because we were looking at the contract, and there were no admin endpoints in that. So every time they were calling admin, we would just stop it, right? Which broke, indeed, their application. And the other thing that we saw in that POC is that somebody, and I never knew if it was actually something that was done on purpose or not, is somebody was returning an authorization header in the response and was leaking API tokens on the response. And nobody was looking at that. Like, nobody is looking if there is an authorization header on the response. Everybody is looking at the authorization header on the request, right? But because we have a policy for that, and we just eliminate all the headers that are actually not supposed to be there, that's how we saw that there were authorization header coming out. And we asked the customers, like, why do you have authorization header on the response? It's like, what do you mean? Right? So it is, and this is all internal, by the way. This is not about external APIs. None of this is exposed to the internet. All right? So it's, yeah, interesting. So it's really important to do this validation, right? And to test not only the requests, again, but also the responses. And of course, you can take advantage of, you know, all the guys which are here in the booth, in the center, the stoplight, the smart bears, the postman, etc. All of them are consuming OpenAPI and allow you to do a lot of testing there, okay? So that's this testing part. And the last one, which might be the most maybe innovative thing, right, is the runtime piece, right? And which is this adoption of what I call a positive security model, which is the idea that rather than focusing on, I was mentioning before, on what it is that we do not want to accept as data, we concentrate on what we do want to accept as data, right, and calls. So we can enforce that indeed the information that we receive and the information that we return is the one that we have designed and approved, okay? And the other key advantage of using something like OpenAPI, or again, async API, or this description, the static description of what the API is doing, is that it is extensible, right? A lot of the companies are leveraging the infamous X dash, you know, extension, which you can create your own with absolutely no problem, and a lot of customers actually doing that too, to add some metadata, if you want, on top of their OpenAPI to take decisions. It could be deployment decisions, it could be, you know, validation decisions, et cetera, et cetera. So you can enrich, basically, this description with more security information. Well, that I said, all right? So the whole point of positive is you're focusing on trust, and basically you block everything except what you know, right? Everything else, so you don't know if it's a threat. Like in our runtime, right, if something comes our way and we stop it, it could be because somebody made a mistake. You know, like we expect a credit card number and somebody made a mistake and they've put a character, an A in there instead of all numbers, and we will stop it. Or it could be somebody just sending an attack, and we will also stop it, right? But we don't stop it because we know it's an attack or we know somebody made a mistake. We stop it because we know this is not a credit card number, right? That's kind of the flip of the, you know, a different way of looking at things. So it's much stricter, that's for sure, right? Also, the main advantage is less false positives in terms of validation, because you have designed and defined what it is that you want to accept inbound and outbound, right? The other thing is the big disadvantage of a negative security model, which is pattern and rule based, is until there is a rule that describes, you know, the infamous log4shell and all that stuff, right? Until there is a rule that describes what this attack looks like, so we can recognize it, it's not known, so it's not stopped, right? So the great advantage of a positive security model is you're not threat focused. So if something comes our way, again, it's a new threat, we don't really care in a sense, because what we're focused on is what it is that we want to accept as opposed to what we want to reject, right? So what can we do with those kind of policies? Well, I just took an example from the Amazon API gateway because they use that a lot, for example. You can enrich your OpenAPI file with some specific annotations, and they will take that and consume it. We'll do exactly the same thing. So in 42Crunch, you can add your own policies inside an OpenAPI file, again, by injecting them. So that's another key thing, which for me is a great advantage of doing it this way, by expressing those policies in a static way, is that you can automate that. We're back to my talk yesterday on DevSecOps, right? One of the things Erez was saying this morning as well, which is very true, which is, yeah, we can do all those enforcements. We know we can do them in the code, or we can do them in API gateways, or we can do this in many different ways, right? And therefore, two things can happen. Or it's not done, because it could be done anywhere, and everybody says, the other guys will do it, so we don't have to do it. And then nobody ends up doing it. Or on the contrary, it's done in 3 different places with different data, and therefore it doesn't work because they contradict each other, right? So what you want to do is to actually automate this. So you say, okay, within my company, there's a certain profile of APIs. And for profile A, this is the policies I want to engage. Profile B, this is what I want to do, et cetera, et cetera. So what taking this approach gives you is, as you publish your APIs through a pipeline, you can enrich your OpenAPI file with such annotations. And that gives you two things. A, you know it's going to be engaged. Nobody can remove this from there. After it's done and this is published, nobody can remove that policy, right? B, it's centrally managed. So if tomorrow I want to change and we say, okay, for this profile now, there's a third thing we want to do, which is to test security headers, which I don't have in here. You change it once in one place, and it applies to all your APIs, right? If somebody is touching this for some reason, you have a trail of it, because you will see this in your GitHub, et cetera, et cetera. So you can track what has been added, when, by who, etc. So it makes it much more transparent. The problem we have with some of the policies in gateways, for example, today, if you just go inside an administrative interface and put it yourself, is that you have no trace of that centrally. Nobody has the guarantee that this has actually been done. Or as I was saying yesterday, nobody has the guarantee that somebody is going to go somewhere and say, oh, I don't know what that thing does. Let me remove it, right? And then they remove it. It goes all the way to production removed. And suddenly, which was the example I was giving yesterday, the partner APIs don't have any authentication anymore, right? So, which is two problems. A, how was it possible that somebody could remove this? And B, how come we didn't find it? Because we didn't test for it, right? Nobody has tested along the way. What happens if I'm calling this API without an authentication? It must not work, right? So they didn't detect that until one of the partners called them and say, is it normal that your APIs don't have any authentication anymore? And that's how they figure it out, right? Which is pretty bad, right? So this is being adopted by a lot of people. There's lots of stuff you can put in there. As the more information you put, the more automation you can put in. It could be describing the data, which is something else that we're doing. For example, giving you a dictionary of data that you can pull and enrich your OpenAPI files from. So now we have limits and constraints that we can enforce automatically, right? So what we would do, for example, is we would consume that. We'll generate the proper enforcement points at our firewall level and then execute them, right? So what is our takeaway of all this? I think I'm done here now. Is really, there's a lot of advantages to describe your APIs using OpenAPI, using async API. And I don't really care if you start from the code and generate the file, if you do an API first and generate the code, if you maybe do take some high-level tools that generate the OpenAPI files, it doesn't really matter. At some point in time, you'll have something that describes in a machine-consumable way what your API is actually doing, right? And you can leverage that for automated testing, automated protection, right? And giving you that scale of security that we're really missing very much today in our APIs, right? So leverage this for doing not only functional testing, but also security testing. This is really critical. If you don't test your APIs, the hackers will do it for you. That's basically what will happen, okay? So you want to know before them. And also this automatic policy injection, right? So you have the guarantee that indeed we do have policies engaged and we know nobody can actually remove them, right, across the board. And that's what I had for you today. As I said, please have a look at what we do on API-Secure.io. Again, this is not, you will see, this is not 42Crunch product at all. It's really educational, and I hope it helps you. And if you have any questions, I'll be more than happy to answer to them. Thank you. Anyone? I don't know what time I have. No, it was all clear and fine. All right. Well, I'll be on the booth anyway with my colleague Andy here, as well as Tom in the back. So if you have any questions for us, don't hesitate. We'll be there until tomorrow. Thank you very much, and enjoy the rest of the conference.